Our final lesson for semester 1 is 5.3, Add, Subtract, and Multiply Polynomials. This lesson is probably the easiest one we're going to do in Chapter 5, so that's kind of a nice way to end. If we're going to add and subtract polynomials, you're literally doing just that. We're going to combine like terms. We always want to write our answer in standard form. Taking a look at each polynomial, adding really just means you're going to eliminate the parentheses right away. So we have 4x to the third plus 6x squared minus 3x plus 2, and then nothing changes in that second parenthesis, plus 5x to the fourth minus 6x to the third plus 8x squared minus 5x plus 11. As we look at combining like terms and writing our answer in standard form, let's look for the biggest exponent. I see in that second polynomial we had 5x to the fourth. There are no other 5x to the fourths, so that is going to be our lead term. And then I'm just going to cross that one off. Then we would have x to the third. I see we've got 4x to the third here minus 6x to the third in that second polynomial. As we combine their coefficients, that just becomes negative 2 or minus 2x to the third. And those terms are done. Looking at x squareds, I see we have positive 6x squared and positive 8x squared for a total of 14x squared. Those terms are done. And then we've got minus 3x and minus 5x. Negative 3 minus 5 would be minus 8x. And last but not least, positive 2 with positive 11 would be plus 13. Literally writing your answer in standard form. With subtraction, remember the only thing to be mindful of is that you're subtracting each term in that second polynomial. This is where I definitely encourage you to write everything out in order to make sure those terms have the appropriate sign out in front. If we're subtracting and we're distributing that negative in, we can eliminate our parentheses. In the first polynomial, negative 7x to the third plus 8x squared plus 3x minus 7 stays the same. But then when we distribute the negative in, we're going to get minus 2x to the third, but then we get plus 6x squared, and then we have minus 3x and minus 2. So be careful when you're doing that subtraction. And now let's look at that first term. I see x cubed as the biggest exponent, and we have negative 7x cubed minus 2x cubed more for a total of negative 9x cubed. That gets rid of those two. And then we have positive 8x squared and positive 6x squared for a total of 14, positive 14x squared. Look what happens here. We have positive 3x and negative 3x. They just automatically cancel. And then last but not least, we've got minus 7, minus 2 for a total of minus 9. And that's what your polynomial would look like in standard form. And that's literally all the practice we're going to do with adding and subtracting. When multiplying polynomials, we've really already done this. We're going to either distribute if there's just one constant or one term out in front, or we'll FOIL. And we'll just end up with more terms than we did like in Chapter 4, for example. Once we get rid of the parentheses by distributing or foiling, we'll go ahead and combine like terms like we did up above. So it says down below, multiply, write your answer in standard form. In our first example A, we have x on the outside times 3x squared plus 6x minus 3 on the inside. To multiply, we're going to distribute the x into all three of those terms. X times 3x squared would be 3x cubed. X times positive 6x would be plus 6x squared. And then x times negative 3 at the end is minus 3x. That's literally what our answer would look like. Our next example, we have 3x squared minus 3x minus 6 times 2x to the third minus 5. What we're going to do here is take the first term in the first polynomial and multiply it to both terms in the second polynomial. 3x squared times 2x cubed, 3 times 2 is 6, and x squared times x to the third, when we multiply like bases, we'll add exponents to get x to the fifth. And then if we take 3x squared times negative 5, that becomes negative 15x squared. Combining that with the next grouping, take negative 3x and distribute it to both terms. Negative 3x times positive 2x to the third would be minus 6x to the fourth. And then negative 3x times negative 5 would be positive 15x. Last but not least, take that constant, negative 6, distribute it to both terms. Negative 6 times 2x to the third would be minus 12x to the third. And negative 6 times negative 5 is positive 30. Whoa, we ended up with a lot of terms there. Taking a look at them, there actually aren't any like terms at all. We have all of our exponents represented. To write this though in standard form based on the directions, notice x to the fifth is the biggest exponent. We'll start with 6x to the fifth. Then we have minus 6x to the fourth, minus 12x to the third, minus 15x squared, plus 15x, and then plus 30. There is your product in standard form. Having 3 parentheses, I believe we've actually done this before, so this one actually isn't really even new. What we do here is just start with any 2 of them, and it doesn't matter which 2 you start with. So now I'm going to FOIL. If I do x times x plus 5 and then negative 2 times x plus 5, we would get x squared plus 5x minus 2x minus 10. Combining those terms in the middle, that gives us x squared plus 3x minus 10. Since we have to multiply that with that x minus 9 on the right, let's make sure to put that in parentheses and then drop down that x minus 9. And now we're going to supersize FOIL like we did in the last example. Let's take x squared and distribute it to both terms. That would give us x to the third minus 9x squared. Take 3x, do the same thing. 3x times x is positive 3x squared. 3x times negative 9 minus 27x. And then last but not least, that negative 10 to both terms. Negative 10 times x is just negative 10x, that product. And then negative 10 times negative 9 is positive 90. Notice we do have some like terms, and what's kind of unique about this scenario is that they're in the correct order. So we'll start with our x cubed, and then if we combine our 2x squared terms, that gives us negative 6x squared. Our 2 linear terms are side by side. Negative 27x minus 10x would be negative 37x. And then our constant at the end is 90. And there's that product in standard form. For our last example, 2x minus 7 cubed. Be careful on this one because we're not, hang tight, really be careful on this one. We're not going to distribute the 3 in. Remember, that only works if it's a product. We can't do that if it's addition or subtraction. So what we need to do instead is literally write this out 3 times. 2x minus 7 times 2x minus 7, you guessed it, times 2x minus 7. Like example C, we have 3 parentheses. Let's start just by grouping 2 of them together. We'll FOIL that one, and then we'll multiply it with the end. 2x times 2x is 4x squared, and 2x times negative 7 is negative 14x. Negative 7 times 2x gives us another negative 14x, and negative 7 times itself is positive 49. Combining our like terms in the middle, we have 4x squared minus 28x plus 49. Now what I want you to do is drop down that 2x plus 7, minus 7. Don't do plus 7. 2x minus 7. Go ahead and supersize FOIL this and combine like terms, and then we'll see if we have a match at the end. So pause the video now, complete that task, and then press play. Our last product, when you multiply 2x minus 7 to the third power, you should have 8x cubed minus 84x squared plus 294x minus 343. And that's it. These are our examples when you add, subtract, and multiply polynomials.